All right, so we're on 3.3 sine and cosine functions. So what we're talking about here is we're going to define the trig functions using isosceles right and equilateral triangles. We're going to define the trig functions on a circle of radius r, find coordinates x and y, given angle and radius of an angle in standard position. Your 3.3 assignment is a Pearson assignment, FYI. So it's already on your thing and already there, but it is a Pearson assignment. Got it? So there's no, I think Friday.
That makes sense because it's on.
Yes. All right. So in our last unit, last section, we explored angles on the unit circle, right? And then you review, analyze those angles on your unit circle for your due now today, correct? Yes. Navigating around and turning your assignment today. So what we're going to talk about is finding exact trig values using geometry. So if you look right here, we have the terminal side of an angle contains the points -5, 3. And we're going to find exact values of the sine and cosine and just trig for fun and giggles, just to make sure we can do that. So the best way to do this is to think of this as a triangle. So this is my initial side. This is my terminal side. My terminal side is telling me where I'm ending. Let me write. Right. There we go. So what we're going to do is think of this as a right triangle and use our knowledge from geometry, okay? So we have an x and we have a y. Our x tells us our horizontal distance, correct? So the horizontal distance here is -5. Our y tells us our vertical distance, and our vertical distance is 3. Are you with me? Okay. In geometry, you learn about Pythagorean theorem. A squared plus b squared equals c squared. In trigonometry, that translates to x squared plus y squared equals r squared. All right. So, am I miss? What am I waiting for? Am I good to go? Okay. All right. So, we have our x, we have our y, but what do we not have? R. So, we're going to find our r. To find our r, we're plugging in set values into this function. So, our x is -5. Our y is +3. And we're going to evaluate. -5 squared is 25. 3 squared is 9. And that equals r squared. 25 plus 9 is 34 equals r squared. So therefore, r equals the square root of 34. I can't simplify. I can't break that down. So this is as far as I'm going to go for the radius. It's 17 times 2, and both are prime numbers. That's an approximation value. We want exact value. This would be non-calculator. Okay. All right. Questions about find the radius. Okay. Now that I have the radius, notice it says no decimal. We're going to leave everything in radical and fractional form. Rational and radicals are our friends. Okay. All right. So next we're going to find our sine and our cosine. To find your sine of theta, remember sine theta equals y divided by r. What is my y? What is my r? Square root of 34. So therefore, sine of theta equals what? What is it? What are we not allowed to have? Square root of the denominator. So it becomes a square root of 34 over 34. That's our proper way of writing it. I did too. I didn't add extra 34. I multiplied the numerator and denominator by the square root of 34. You multiply by the radical. All right, so cosine of theta. So we're going to do it again. Cosine of theta is what? X over r. So what's our x? Our r. And when I ratify this, it's going to get And that is my cosine. So we found our sine, check. We got our cosine, check. Was that terrible?
Question.
Yes. It is improper and it's harder to determine whether it's a zero or not because the radical already has its restrictions on the domain as well, is what I was told.
But mathematically it works, right?
Yeah, I mean it's like remember I told you it's like a sentence is still a sentence just missing a comma, right? It wouldn't if it's typing, no, it would not. So in Pearson, if you do not write it in proper form, it would be incorrect. On paper, on um on paper, you would get partial credit because you did not simplify or ratify. Yeah. Guys, all you did was multiply. It's like one little tiny step. That's it. If I was an English teacher, I would count you off for your grammatical errors, right? Okay, same thing here. Yes. That's terrible. I've read some of the writings I've seen. Yes.
What, not really to this, what time is what day and time does the, test?
Thursday after school.
But can you go back to?
Sir?
I can't go back into it.
Okay. All right. So here we go. We have sine theta equals 5/6. So this one's a little different. It's telling us what our sine theta is, right? So it says sine theta equals 5/6. What this means is that it's telling us our y and it's telling us our r. Does that make sense? Yes. Okay. So it's telling us our y and it's telling us that our r. So that means if you're drawing it, you have a radius of 6 and a vertical change of 5, but you do not know your x. So we're going to solve for x. Again, when we're solving for the x, we're still using x squared plus y squared equals r squared. So we have x squared equals r squared minus y squared. Make sense? So we get x squared equals 6 squared minus 5 squared. Yes.
What's the point of this, where, because here you just like swear with all of them, wouldn't that be the same as?
No.
Why not?
What 6 minus 5 is not 11. It's not the same. All right, so now we have the value of x. So it wants us to find cosine and tangent. Can I find cosine and tangent now? I surely can. Remember, cosine of theta equals x over r. Our x is square root 11, and our r is 6. And that's the answer. All right, now we're on to tan theta. Tan theta equals y over x. What's my y? 5, and my x is square root 11. This is an okay answer. It's not perfect. How do I make it perfect? 5. There we go. Okay. So we have our cosine is square root 11 over 6. And we have our tan theta is 5 square root of 11 over 11. Well, guess who's turning this? No. Oh my God. All right, it's your turn. So this time I'm giving you tan theta equals 4/7. So what information am I giving you? And then use that information to create a graph. All right, here we go. So, tan theta. I'm in quadrant 3, so that means that my y and my x technically are negative. So in quadrant 3, I gotta sneeze.
I didn't do that.
Oh, bless me. Thank you. Okay, so tan theta equals -4 over -7, which means that oh, thank you. Because it's in quadrant 3. So they both have to be negative, right? Where do you see pi? Tan of theta is 4 over 7. That's my y over my x. So that means here, my angle, it goes over.
What I'm saying is, why does it not just put -4 over -7?
Because a negative divided by a negative is a positive. That's it. All right, so we have -4, we have -7, and we had to find the r, correct? So when you found your r squared equals -4 squared plus -7 squared. So r squared equals 49 plus 16. I know I wrote them out of order, but my brain made me put the big number first. Sorry. Which equals 65. So therefore, r equals the square root of 65. No bueno. All right, so sine theta. Sine theta equals y over r, right? Y over r. So -4 over the square root of. There we go. Our cosine theta. Cosine is x over r. X over r. And our x is, guys, y'all just let me be doing weird things. And no one says nothing to Miss Jones. Just let her.
Oh, I did that one too.
Y'all just let me out here and just embarrassing myself. Huh? I surely did. All you can do is laugh. Oh, let's try that again. All right. So we get -7 over the square root of 65. So negative square. Oh my gosh, y'all are geniuses. How do we feel? Doable?
Oh, you messed me up. I was right.
I didn't do nothing. You're supposed to be telling me I did something weird. I refuse to take the blame. All right, so tying it all together. When you are stuck and you cannot remember a value, as long as you know that the reference angle is a 30, 60, or 45, then you can always just remember your geometry. You can always go back to using your triangles. So when you're going around the unit circle and you can't remember a certain value, remember the triangle. Okay. So the reason why we say remember the triangle is because if I'm asking you for the sine of 60, remember the sine of 60. If I ask you for the sine of 60, sine is opposite over hypotenuse. My opposite is square root of 3. My hypotenuse is 2. So guess what the y coordinate at 60 is? Square root of 3 over 2. If I asked you for the cosine, remember, cosine is adjacent over hypotenuse, so it'll be 1 over 2. So the x value at 60 is 1 over 2, right? So these are just a little tidbit to help you. But what you do need to remember is SOHCAHTOA. You say what you want to say, tomato, tomato. I've been saying SOHCAHTOA longer than you've been alive. I don't care. Okay. My teacher taught it as some old hippie called another hippie tripping on acid. That's what my 8th grade teacher told us. Nope. Her name was Mrs. Ehamberry. Yes, it's an African name.
Oh, wow. It sounded like, because we were talking about tripping on acid, and I was like, wait, what is this?
No.
It's actually on acid. Sorry.
No, it's actually an African name. Some old hippie caught another hippie tripping on acid. Okay. And this comes in handy when you are struggling. So when I was trying to memorize the unit circle, at the top of my unit circle page, I always drew my triangles. The reason why I drew the triangles is so that if I got stuck on one of my angles, I would go back to the triangle and say, okay, the reference angle is 60. Because my reference angle is 60, then I'm now going to be using sine, cosine, and tangent. Does that make sense? So that's always an option, and that's how it works. So what I want you to do is we're going to complete the table right here using only the triangles. Okay. So using only the triangles and sine Sokotoa, you're going to figure out only the triangles. Got it?
Wait,
Finding the sine value. So find the sine of 30, the sine of 45, the sine of 60. Find the cosine of 30, cosine of 45, cosine of 60. Okay. So you're using the triangles to fill in the table. Yes? Remembering the fact that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. This is a tool to try to help you remember how to fill in the unit circle coordinates. Okay? All right, go.
Oh, wow.
So, nope. Just remember the conversation. Look at the beautifulness of this. Who's not here, Randy? Everyone's here. We go. Oh, Josephine left early, but I think we'll be okay. All right. So now we're flipping over to part B of our notes. So flip on over. Part B is like us putting a ribbon on 3A, like tying it all together. Okay. So on part B, we are making sure that we have a clear understanding of how everything works. Does that make sense? Yes, and how it's all intertwined and leads from one thing to the next. Okay. So example number 5, we have the figure here at the right. We can solve for sine theta simply as long as we know the y and the r. Agree? We can solve for sine cosine theta as long as we know our x and our r. Cosine is x over r. And we can solve for our tan theta as long as we know y and x. Correct? Okay. You can also solve for y and x using the theta. Okay. So if given theta, you can also. And so the rule is y equals r sine of theta. Your x equals r cosine of theta. And again, the tangent is still going to be y over x, aka the slope of the line. The change in your y over the change in your x. So now, if I know my radius and my theta, I can automatically find my x and my y. Does that make sense? Yes? We start building on? All right. Yes.
Are you staying after school?
Am I staying after school? Yes.
Wait,
Okay.